Okay, grade 12. So I'm going to take you through pages 593 to 599 and just point out some important things on here, this page, okay? And kind of help you understand what you're reading. So on page 593, you have the life table for bluegrass, okay? And as you're looking through this table, this is all it's simply showing you. Is how many bluegrass plants are alive at the start of an interval and how many are alive at the end. So if we look at this column here, we notice that all bluegrass is going to be dead at 25 years old. So they don't live past 24 years old. The number dying during the age interval. So between 0 and 3 years of age, you get 121 plants dying. Between 4 and 6, you get 195. Between 7 and 9, you get 211, which is our biggest loss there. And then slowly they trickle off to 0. Okay, age-specific mortality rate. So now we're looking at a rate. Okay, a rate will usually be expressed as a decimal. If you don't like it as a decimal, then you multiply it by 100 and you would say 14% or 14.4%, 27%, 40%. So between ages 7 to 9, we lose about 40% of those bluegrass plants. Okay, and then age-specific survivorship is the opposite. Okay, so these are exact opposite numbers if you have a look at that. So this asks you how many plants are still surviving. So between 0 and 3, after that group, after that age interval, you have 85.6% of the plants still surviving. And then that's all that tells you there. Okay. Cohort, that's an important word for you guys to pick up in this unit. A cohort is defined here. It says a group of individuals of similar ages. So when you're going to follow, particularly human beings, okay, what we do is we look at people within a certain age. So your cohort might be everybody in high school right now, okay? And we would follow all the grade 9s, 10s, 11s, and 12s if we wanted to do a study on how, for instance, technology is affecting you. We would look at you now, and we would look at you in another 5 years, and we would look at all 4 grades again in maybe another 10 years. So why do we look at cohorts? Because they're experiencing the same things at the same time. Okay, so you're experiencing a pandemic right now where other people wouldn't have experienced that in high school. So a cohort is an important word because it refers to a group of individuals of similar ages, and we study cohorts particularly with human beings because we need people to have similar experiences at similar ages so that you block out all other important factors. Okay? All right. They give you examples here on how they calculate the rate. So this is important. Okay, a little bit of very easy math. So if we're looking at age-specific mortality rate, the number of that have died during the interval over the number alive at the start of the interval. Okay, so we have 195. I don't know that this refers to this example. Yes, it does. Okay, so between ages 4 and 6, we have 195. That's where they're getting that number from. And then 722 is how many were alive at the beginning. Okay, so we're comparing this number to this number, and we're dividing this number by that number. And that's how we get this rate. All right. And then if we were to reverse that, we want age-specific survivorship, you actually subtract. So you take your 722 and subtract your 195 and divide it by 722. Again, we're dividing by 722 here as well, okay? So this one is a different formula, but this is how you're going to get age-specific survivorship. This is how you're going to get your mortality rate, all right? And so what I want to take some time to look at with you, just pretty quickly here, are your survivorship curves. Okay, so this is always known as your type 1 survivorship curve, type 2, and type 3. Okay, and if you're wondering why I'm not giving you notes, it's because the textbook does a very good job of this unit, okay? And we're just going to go in as much depth as the textbook gives us at this point. So what I want you to be familiar with is the type 1 survivorship curve starts out really, really flat at the top. Okay, so we notice this. And then it has a significant decrease. So what is this showing you? This is showing you that if you had 1,000 organisms, and so they're giving us this type of a mountain goat or a ram. If you started with 1,000 individuals, this individual over time, okay, so this is over time. We're going to say it's 100 years. These guys don't live to 100 years, but we'll just pretend it's 100 years. They drop off very, very slowly. So in other words, your chance of surviving if you were one of these organisms in your early life is excellent. Okay, you have a really good chance. Now there's a little bit of a drop. You're going to lose some babies, but overall they're going to do quite well, live a good life, and then die because of old age or other things, right? Like they're more susceptible to predators as they get older because they slow down. So this is the kind of survivorship curve you and I follow. All right. And I did post on the LMS page another different example so that you could see that. So this is our survivorship curve. We do really well at the beginning of life, and then we drop off slowly as we get older, which makes sense. That's a very good type of curve. Now, here's type 2. What you notice is that it doesn't matter what age you are, you have an equal chance of dying at any time. Okay, so life is very unpredictable for these guys. All right. What I want to say to you guys. This means that you've got constant factors affecting your life. Okay, so type 2, in other words, lizards, they could do really well for a couple years and then something could eat them. All right, so it's unpredictable as to when they're going to die, but there's nothing saying that they're going to do really well at the beginning of life and then suddenly drop off, or not do well at the beginning of life and then thrive after. Okay, so constant mortality rate in type 2 survivorship curves. Type 3 survivorship curves, okay, are very different. So they're pretty much the opposite of us. So you see that you get a whole bunch of offspring being born. I'm going to go with sea turtles on this one. Okay, you get a whole bunch of eggs hatched, but those eggs, those sea turtles have to get into the water first of all, and then they have to get further into the deep water and avoid predators on the beach and avoid predators in the water. So in other words, your chances of surviving when you're brand new are very, very slim. You get this huge drop off, but if you can make it past your first year or 2 years, we'll say, then you've got an excellent chance of surviving after that. Okay, and so you can see they can live a very, very long time. You get a lot of the population dying right away, but then it tapers off and organisms can survive. So if you've beat the odds at the beginning of your life, your chances are excellent for a long life. And again, sea turtles are a good example of that. Okay, and then what we go into here is fecundity. So I just thought I'd show you this with fecundity. So these guys are opposites. So fecundity says it's the potential for a species to produce offspring in a lifetime. So how many offspring are you going to leave behind? It's kind of like evolutionary fitness, all right? Something that you would have learned about in grade 11. If you want to think about it that way and it helps you, that's awesome. But it discusses how many offspring are you going to leave behind in a lifetime. So an elephant, we're going to start with this, has a low fecundity. You and I, human beings, tend to have a low fecundity. So it's a very different strategy at life between these two organisms. She is going to take care of every calf she has until the calf is able to take care of itself. So very few offspring born at a time, okay? High parental care and involvement, and then another offspring once this one is ready to take care of itself, okay? You can't say that about humans because a 3-year-old human is not ready to take care of itself, but humans will have, generally speaking in 2020, will give high parental care, okay, and we won't have so many children that we can't take care of them all right? Very much the same strategy as a whale, an elephant, etc. So we have low fecundity rates. When you look at a horseshoe crab, it says it can lay 90,000 eggs in a single spawning. Now, she lays the eggs and then she's gone, right? And so these guys are left to take care of themselves. So very high fecundity rate. They're lower on the, what am I thinking? Sorry. They're lower on the food chain. So you're going to have a lot of these guys produced, a lot of them eaten, but a lot of them will survive. And her fecundity rate is huge because she has left her genes behind. Okay. So different strategies: leave a lot, hope for the best. Okay. And many will survive. Have few and take excellent care of them, and they will survive generally. Okay. Generally speaking. And I think that is it. Yes. All right. And then they just go over here. And again, just discuss what I went over with you. High fecundity versus extensive parental care. Very different strategies.